Thank you, Mark.
Thank you. Good morning, everyone. Thank you for choosing to be here this morning. I know it's difficult to wake up after several days of this conference because you take in a lot of information and there's a lot going on, all these keynote sessions, and you decide to wake up and come to this session. So I greatly appreciate that. Thank you. So my name is Mark, and I am from Thailand, which is where I currently live, but originally from the USA. And today my talk is about how we can have more play and more fun in education, specifically with regard to speaking about technology education. Before I get into my workshop, my session, I want to talk a little bit about some things that I've learned while I'm here at this session. So one of the conference threads was about social emotional learning, and I attended a few sessions. And one of these quotes, it really stuck out with me, and it's here on the screen. Educating the mind without educating the heart is no education at all. And so these threads about social emotional learning, I think, are a very important conversation to be having, because in education, you really need to build connections with students, and you need to basically get to their hearts so that they can learn. So today, my goal with you is to make a connection. So whether you make a connection with me or you make a connection with someone in the audience, the goal is for you to make that connection so that learning can actually happen for you. Another thing that I want to share is I met these amazing students. They're local students here in Visakapatnam, and yesterday they were in the Dell conference room, and they were showing off their mechanical and electrical engineering prototypes. And they had their goal was to solve a problem that exists in their world. And they were tackling problems like agriculture and trains that have a problem with leaking pipes. And so they designed prototypes, and they used circuit boards, and they could program these circuit boards to control motors and to control sensors. And they even built a miniature robot that's used in agriculture. And so it always warms my heart when I see students building these kind of things and using technology and learning so much about it along the way, but not just in a way that is for entertainment, but they're actually thinking about real problems and solving real problems with their ideas. So I don't know if they're going to be here today or not, but if you haven't seen this, their demonstration is quite amazing, and they can tell you all about what they learned and about the problem that they're solving, and it's very interesting to see them. So today my session is about play, and in education I think it's very valuable that that play is part of the structure of how we teach. And so I want to share just a memory that I have about play. As a child, I would often take apart things, much to my mother's dismay. But I would take apart things like an old lawnmower and remove the gears and remove the motors, and I just want to kind of see how it looked on the inside. I was never able to get it back together quite the same way, so I think I usually broke more things than I fixed. But I always just had this general curiosity about how things work, and so I would always play with tools and play and take things apart, put things together again, and I think I was maybe trying to invent a spaceship or some crazy contraption like that. So what I would like for you to do is turn to someone near you, and I want you to think about a fond memory that you have where you were playful, where you were playing with some toys, or maybe you were making something, and introduce yourself. Say, hello, my name is, and where you come from, what do you do, and then talk about some memory that you have where you were playful, where you got to play with something that's maybe stuck out with you as a childhood memory. And we'll take a few moments for this, and then afterwards, maybe some of you can share out loud to the audience your conversation. Okay, so do that now, please.
after they complete, they have to get it from there. Okay. Sure. ఎప్పుడు వెళ్ళిపోతుంది స్టార్ట్ అవుతుంది ఏం డిస్కషన్ జరుగుతున్నాయి వెళ్ళి జాయిన్ అవ్వండి రా ఇంటికి వెళ్ళాక డిస్కషన్ జరుగుతుంది గేమ్స్ డిస్కషన్ అన్నారు తర్వాత మీరు జాయిన్ అవ్వచ్చు
These kind of things are how we learn. Okay, hopefully you had just a moment to speak about the nature of play and a fond memory that you had as a child, or maybe sometime when you were in grade school. And I heard some great conversations happening about some games that people would play. And these are the kind of memories that we have in our minds. Nobody has the memory in their mind of whenever they took the 5th grade math test, right? I mean, you may remember that you don't like that, but you don't have this fond memory of it, these things that stick in our mind. And I heard from this group right here, like there's even some like math games where you are active and you're jumping and to memorize like the multiplication table or the names of places. And so teachers have been using these kind of strategies for years and years, making games and making play out of education. And the more that I travel around the world, the more that I see that this kind of play and this kind of having fun in education starts to disappear. So it is my goal to kind of bring these kind of ideas back into education, especially in the world of technology, where technology can be very structured, where it's always on a computer, always doing one thing and then the next thing and then being rushed on to continue. So it is my goal to have a little bit more fun with technology. Do we have the speaker block that we can pass around? Perhaps somebody in the audience wants to share a memory that they have about a fun time where they were learning something with play. I think this group right here was having a good conversation. Maybe there was something they could share, please.
Yeah, so
Thank you.
I remember I was always like playing outside with my sisters and playing outside in one particular tree, and it was like our home. So I remember this being really playful moments for all of us actually. So yeah.
Does anybody else want to share some fond memory that they have of playing? Can we pass it right over here to this group right here? Because these ladies were having a great conversation about some memories that they have.
Okay, so we used to play a lot of, there was not much of television when we were young. I'm a 90s kid, so 80s, 90s kid. So we were more on the outside than on the inside. So we used to actually create games, and we used to invent a lot of things which were in our innocence, helping us learn so many skills and other things also. So there was this one game that, if anybody can actually synonymously understand this word, it's called Pittu. And it's actually a game of 7 marble pieces which you put and make like a Tower of Hanoi. And there are 2 teams, they have one defense, the other attacks, and they have to break the other one, and then they keep on hitting each other with that tennis ball, and it's really hard, and you really throw it with a lot of force. So the tricks that we learned at that time was how to win, was like, if you throw it at the real foundation, you would be breaking it out. So those kind of things, you learn, architectural skills you learn, collaborative teamwork you learn, and this is something that we are able to understand only when we grow up. That, we used to be, this is my team, this is our team, and there was also talk about kabaddi that we used to play, that, possibly the best teamwork game that we have ever learned is, hold your breath, and it's like a lawn tennis game. So one person from one team goes to the other team, and they just have to touch someone, and then you are an out, then you're not playing as a part of the game anymore. So it's those things, and bring out the best part of the physical exercise, which I think with nowadays everybody being online, that becomes a little difficult. So fondness is there because the friends that we make on the court at that time, and the skills that we learn, and the teamwork and the things that we learn, it's really great.
Yeah, thank you for sharing. And I think it's important to recognize that play is a team activity. And so it requires you to play with someone else. It could just be one other person, but it's better the more people that you have. And you start to learn these kind of skills even though you don't know it. So you're having fun, but you're learning collaboration, communication, trade-offs, agreements, disagreements sometimes. So play is very valuable. So I'm going to continue with my talk. And let me tell you a little bit more about what I do and my work. So I travel all around the world, and I help teachers and I help schools design makerspaces. If you have heard of makerspace, please raise your hand. Makerspace is kind of a new concept in education, and it's something that I feel very strongly about. And so what I do is I help schools to design makerspaces, and then I help them to develop lessons and activities and projects that students can do where they're building and making things using technologies. In the photograph here, I have some students who are building a prototype of a wind turbine. And the prototype of the wind turbine that they made was to simulate how they could collect energy using the wind to power a small schoolhouse in Argentina. And so these were some students that I was working with in Hong Kong, and they developed the prototype in Hong Kong, and then they give the schematics and the diagrams to the teacher in Argentina, and the team of students in Argentina were making the full-scale model of this one, which is currently in construction right now. So these are the kind of things that I like to work on. I like to have students build and make things, and we have a little bit of fun along the way. When I was in the USA, which is where I was born, I had a program where we had a mobile classroom. And the classroom was this gigantic bus. It was called the Geek Bus. And inside the bus, we had 3D printers and robots and workshop tools. And I would visit the little towns and villages along the border of US and Mexico. And these were areas where students did not have access to technology. They had never seen a 3D printer or a robot of these kind of things. And so we would go to these local villages, and we would help these students learn about these technologies. And then we would ask them like what kind of problems they could solve in their community. So much like the photo that I showed you earlier of the girls here that are local, we were doing a similar kind of project, but had this all on a bus, and we would take it around into these towns and villages to teach children. So this is kind of the things that I work on. And I'm currently a PhD student at Chiang Mai University in Chiang Mai, Thailand. And I'm studying a branch of education called constructionism. And maybe you've never heard of constructionism, but it's the theory and the pedagogy of building and learning at the same time. And we do this through learning about how students use electronics and robotics and computer science. So this is something that's deeply interesting to me, and I do a lot of research and collaborate with people all over the world for this topic of constructionism. I also currently work for a company called BSD Education. BSD stands for Build Something Different, and we provide curriculum and lessons and professional development to teachers all over the world in regards to computer science. So where students are learning how to program, how to build websites, how to do virtual reality, artificial intelligence. They're even doing hardware with robotics and circuit boards. And so I work with this team, and we develop curriculum, and we help teachers to implement this in the classroom. And we currently have teachers using our curriculum from all over the world in 11 countries and over 100 different schools. So I want to come back to this idea about a makerspace. And whenever I help schools around the world to design makerspaces, it's usually at a technology-focused school, and they have a really big budget, and they want to have a 3D printer, and they want to have a laser cutter, and there's mechanical machines and lots of robots. And these are things that I can help schools do. But I have a much larger theory about what a makerspace is. And if you just break down the word makerspace, a maker is somebody who can make things, and a space is a place where you do that. Well, if we can make things in this space right now, we could call this a makerspace, could we not? Yes, and perhaps we will. I brought some tools that we can use, and we can make some things. So there's, in the realm of education, this idea of having a makerspace, to a lot of educators, it means that you need to spend a lot of money and buy expensive technologies. But for me, I think that that's missing the mark. It's not what's important. What's important is what the students are focusing on, what they are learning about, what they are doing, and more importantly, what is the purpose of what they are doing. If you just learn how to build a robot, or if you just learn how to program a computer, that's an excellent skill to have, but it needs to have a purpose. It needs to have a reason for why you're doing this. It needs to be connected. And like in my slide earlier with the social emotional learning, there's importance about connection. If you connect the heart to the mind, then learning can really happen. So for me, what's more important than the tools and having this fancy, expensive equipment is about the people that are in the space, the teachers and the students, and about the philosophy of the space. And so earlier I told you about the educational pedagogy that I am studying in my PhD called constructionism. And I'll speak to you more about this idea and this philosophy about how we can have students be playful and how they can learn with building things hands-on. This is a photograph of a makerspace that I was working at in Hong Kong, and we have students and teachers working together. This is a woodshop project where they were building stools in the library, because in the library of the school, the shelves were too high for the small kids to reach. And so they could never reach the books on the top shelf. So the students, they identified the problem that exists in the school, they built a prototype of it, and then they actually built these steps. And so now the library has steps that they can move around, the little step stools, and so the young children can reach the top shelf. So instead of just teaching these students how to build something with wood, we taught them how to do it by solving a problem. So there became a purpose, a reason for why they were doing this. So to speak to you more about constructionism, the name constructionism came about from a student at MIT University named Seymour Papert. I don't know if any of you have heard of Seymour Papert. Raise your hand if you have. A few people, yes, good. And Seymour Papert was a student of Jean Piaget, who was a famous educational psychologist, right? And so in his field of work, Seymour Papert was studying long ago, in the late 1970s and early 1980s, he was studying artificial intelligence, but specifically with how children can learn about computers. And so he worked with students, and he developed a language in computer science that students can use and it was called Logo, and they used this turtle device. So you can see on the screen, there's this big dome, and it's a mechanical robotic turtle, and it has a little pin on the base of it. And when you drive the robot around, it leaves behind the mark of where it was, so you can draw on the ground with this, but you have to program it and tell the robot which way to turn, when to turn, how much to turn. So constructionism is this idea that assumes that learning is most effective when students are making things, when they are using their hands. So the word constructionism, the root word construction means building something. But it's not just about building something in your hands, it's also about building something in your mind. And so the way that we learn new things, if you learn a new fact, the way that most people think about the brain is that you just store that fact away in your mind somewhere. Well, if that's the case, those are the kind of things that you tend to lose. But if you construct new knowledge inside of your mind with other knowledge that you already have, then that's when real learning takes place. So this idea of constructionism isn't just about building physical things, but it's about building models inside of your brain. And Seymour Papert, he had a very famous saying, and he said, "You can't think about thinking without thinking about thinking." So it's very metacognitive, right? So when you're learning, when you're building something, you're not really necessarily thinking about what you're doing, but it's just happening. And because of that, you start to build these connections in your mind. So thus, this term constructionism came about, and it's something that I study and something that I research, and I think it's a very, very powerful methodology for students to learn. One of the companies who also really believes in this idea of constructionism is Lego. Raise your hand if you have played with some Lego blocks before. Oh, good, yeah. It's like an international toy that is recognizable anywhere in the world. So if you think about Lego blocks, they're very simple tools, very easy to use. You know, young children can use them, and even adults can use them as well. So Seymour Papert in the 1980s was working with the Lego company to develop their first Lego robotic system. So this is the Lego robotic system that's called Mindstorms. And so together at MIT, Lego and Seymour Papert, they worked together to develop this kit. And what they wanted was a kit that any child could pick up and start using, and it needed to be simple so that you could get started without a lot of expert knowledge, but also it needed to be easy for students who have a lot of knowledge to build some really impressive things or to take it further and go beyond. So Lego has, all of their products have this idea in mind of constructionism, where you can start off with something simple or you could make something extremely complex. So there are three things that make something a constructionist technology. The first one is that it has to be easy to get started. Anybody can pick up Legos and play with it, right? You don't need any special skills. There is room to go deeper, which means that you can take what you have and make something much larger, something more complex, something more complicated. And then lastly, it has to be designed for play in mind. So it needs to be fun, it needs to be engaging, where you can just have a good time with it without any specific learning goals. So here's a photo to show an example where Lego, just the blocks themselves, have room to go very deep. So maybe if you were playing with Legos, you would build some little small structure, but if you wanted to, you could spend hours of time building something like this, this Roman architecture, right? Very detailed. Lots of time went into making this. So this constructionist technology has room to go deeper, it's made for fun, and it has an easy place to start. Here's an example of the Lego robotic system. So this is a photograph of a student who made a miniature manufacturing robot. And this robot can identify the color of different parts, sort those parts, and then it goes to make like a conveyor belt. And this is just one part of it, and it's connected to other robots. So in this example, it shows where there's room to go deeper with the technology. Not just simply playing with it, but really taking it to the next level. So the Lego company actually works with Harvard University and MIT, and they work with researchers, and they study children and how they learn when they play. And they've come up with these 5 characteristics that children are interacting with when they are playing. So the 5 characteristics of play, according to Lego's research at MIT and Harvard, is that it has to be joyful, socially interactive, mean working with other people, more than one person. It has to be actively engaging, meaningful, and the last one, iterative, means that you can do it over and over again. You can play it again. You can try again. You can take it apart and build it again, okay? So earlier when I asked you to think about a fond memory that you have of play, what I want you to do now is revisit that conversation, and I want you to talk about how that experience that you had of being playful was one of these characteristics. Maybe you can talk about that a bit more, about how either it was joyful or meaningful or actively engaging or socially interactive. And if you're just joining us, we had a moment this morning where we were discussing a memory that we have about play. So it could be something from your childhood or something from your grade school where you were being playful, having some fun, maybe building something, playing outside, a game that you have with your family, and what that meant to you, okay? So let's revisit that conversation that we had, and then now let's talk about one of these 5 characteristics and how that impacted the play that you had. And we'll take 2 minutes for that. Go ahead. Okay, I'm gonna keep on with my presentation. Sorry if I interrupt your discussions. But so earlier when we talked about play and some of the conversations we were having, these characteristics are things that you were talking about. maybe you just didn't use this vocabulary to describe it. But we talked about how when you are playful, you're socially interactive, which means that you are working with other people, you are having discussions, you are coming up with ideas together, you have to figure out the rules together, maybe you argue or disagree about those rules and come to some kind of conflict resolution. So this idea of the pedagogy of play really kind of like rounds out all of the ideas, the characteristics of play. So these are the characteristics of play. Now in the Lego pedagogy of play, I'm going to show you what play can do for you. So these 5 areas are the areas where play builds the strength in physical activity, social activity, cognitive means in your mind, emotional, and creative. Okay, so these are the kind of things that students naturally want to be involved in. You don't need to convince students that these are the things that they want to do. As a matter of fact, if you're a teacher, you probably see students doing this kind of thing when you don't want them to, right? Yes, you're trying to teach and they're in the back playing, okay? Because that's what they want to do. This is their natural state. Their natural state is they want to be involved in these kind of things. So if you can tap into their natural states and make your lessons and activities engaging and make them more playful, then they're more likely to engage in that with you. And that is when learning can take place. That is when this idea of constructionism, you can use your lessons and your activities to build new knowledge because the students are playing, they're connected, they're using these ideas of play because it's natural to them. Okay, and I think this makes common sense, right? When I speak about this, you don't really need to understand the whole theory of constructionism and the pedagogy of all this. Kids want to play, right? That's what they want to do, and so it is our goal and our job as educators to give them the opportunity to do this. But we need to refine it in a way that they are learning what we want them to learn through this idea of play. Okay. So this is a quote from Seymour Papert again. It says, rather than pushing children to think like adults, we might do better to remember that they are great learners and try harder to be more like them. So this is where I reflect on myself as an educator. And I think it is my job to set the tone in my classroom that it's okay to be playful. And so in my classroom, I'm kind of like goofy and I play with the students and we make jokes and I have like a ball in my classroom and sometimes I just throw it at the kids and see what they do and you know, just kind of liven up the space a little bit with the students. And there's a really great video of Seymour Papert before he passed away where he would visit these schools in Vietnam, in Thailand, in India, and he would just go right in with the kids and have fun with them and start playing with them. You know, an old man, 70 years old, just having fun. And so I think that's going to be me someday. I'm just going to be an old man going to have fun, play with kids, teach them things. And so I really value these ideas about being playful. And I think that as adults, we tend to get very critical, right? And we get stuck in our ways, and we make things we make things so structured, and we make things so boring, right? Sometimes we make things boring. Like if I'm just talking at a keynote for an hour and I want to make you listen to it, wouldn't it be better if we got to play in that keynote? I think so. Yeah, so that's why I like to have fun. So do any of you have a laptop today? We got a couple of laptops? Okay. So I have an activity that I want us to do, and I brought some circuit boards with me, and this is an activity that you can do with a group or several people. But it's using this circuit board, and this circuit board is called the Microbit. It was designed by the BBC in the UK, and it's meant to be a low-cost, affordable tool. It's a constructionist tool, and if you remember the 3 areas that a constructionist tool must have, is that it must be easy to get started, it must have room to go deeper, and it must be designed for play. So this circuit board, you can program the circuit board. And you can, even if you have never programmed in your life before, you don't know anything about computer science, you can use this circuit board to program. And there is an online environment to program the circuit board, and it uses coding blocks instead of script language to learn how to code. And the great thing about this tool is it's very affordable, I think. So I looked online just yesterday, and you can buy them in bulk for 1,000 rupee, which is about $13 US. And you can have like 1 per every 2 students in your classroom. and you can reuse them over and over again. As a matter of fact, I have one here on my badge. You can see it's blinking the LED lights. So you can design a program that controls the screen of the LEDs to light up and to blink. And this is just a very simple heart. So the heart is beating. You can see like the LEDs blink on, blink off, okay? And each of the LEDs is programmable, so you can make little animations with this. And then if you want to take it deeper, you can add more things to this. Like you can add a sensor to this. You can add a motor to this. You can turn it into a robot. So as any good constructionist tool, it must be able to go deeper so that you can add more functionality to it, okay? So if you've never heard of this, I recommend that you research more about this circuit board called the microbit. So those of you that have a laptop, can you please take out your laptop? And if you could come up to the front, I've got a circuit board here, and I've got some cables, a USB cable, so you can connect your laptop to the circuit board. And if you don't have a laptop, maybe you could just gather around or crowd around somebody who has a laptop. So who has a laptop? Raise your hand. Everybody crowd around them now. Go get next to them so that they can share. So I'll give just a moment for people to situate themselves around the laptop if you have a laptop. And if you do bring your laptop, thank you so much for sharing and being willing to have other people take a look at your screen. Yeah, and if anyone else wants to just take a look at the circuit board, you're welcome to come and grab one as well. Yeah, I think you should be able to connect to the Tech 19. Yes. All right, so if you grabbed one of the circuit boards, please go ahead and take it out of the package. And the first thing I want you to do is I just want you to look at the circuit board and look at what it says on the circuit board, look at the parts of the circuit board, and I want you to see if you can identify any of the parts. What does it do? What do you think it does? What do you think the parts of the circuit board are? Maybe let someone near you take a look at it as well. Hold it in your hands. See if you can identify what you think this circuit board can do. What is it about? What does it have on it? I could show you a slide and tell you all about it, but that takes the fun out of it. The fun is playing, right? You want to just look at it, learn about it yourself. Is the internet working now? Yes. Okay, so in a moment, I'll need you to connect to the internet using the Tech 19 Wi-Fi, and I will give you a URL on a website so that we can actually program these circuit boards. All right, for those of you that have the circuit board, does somebody want to share, raise your hand and share one thing that you noticed about it? What do you see on the circuit board? What does it have? Tech 19 is not working? Can we have some help with the Wi-Fi? All right, so on the front of the circuit board, what are some things that you see on there? Switches. Yeah. So there's the switches, and they're labeled, right? There's a switch A, a switch B, okay? And what else do you notice? What's that? I'm gonna come down here so I can actually hear everyone. What did you notice? Oh, you got, yeah, they have theirs lit up already. Perfect. If you plug it in, yeah, if you plug it in, you see the LEDs, they start to light up. Yes. So on the screen, the LEDs, they light up and it makes a screen. And on that screen, you can have symbols. You can have information. You can make animations. You can have text go across it, okay? If you look at the bottom of the circuit board, there are numbers. It's labeled 0, 1, 2, 3V, G, and D. If you know anything about electronics and circuits, 3V and G and D, that is how you create a circuit. G and D stands for ground, 3V stands for 3 volts. So I could connect wires to this and I could extend the circuit and I can add a motor to this, I can add a sensor to this, I can add a lot of different components, okay? But for today, we're just gonna look at the circuit board itself. Now, if you look at the back side of the circuit board, there is also some more information. There is a reset button, and somewhere on the back side, there's a tiny little squiggly line for a radio signal. So this circuit board has a built-in radio signal. So if you wanted to have these circuit boards communicate with each other, then they can send a radio signal to each other. And so I have a really fun activity in my classroom where I teach the students how to set up the radio signal, and now they send each other messages on there. I think they send messages about me, I'm not sure. All right, so once you kind of just take a look at the circuit board, you've got it plugged in. If you're not sitting by somebody who has it plugged into their computer, just kind of turn around. There's a few people here and there who have the circuit board plugged in. As soon as you plug it in, it's going to light up and it's going to show you what the screen can do and that kind of stuff. But I want to show you how we can actually program this circuit board. So the way to program the circuit board is you need to visit this website. It's called makecode.microbit.org. So this is the URL up here at the top of the screen. So if you visit this website, it's going to look like this page here. So on your computer, please open your web browser and navigate to makecode.microbit.org. And as soon as you get there, I will show you what to do next. Do you find the site? Okay, when you visit the URL, your screen should look like this. You should see the website. So you can start a new project, but actually if you scroll down on your screen a bit, I'm looking for a image that looks like this. It's a tutorial, and there's several different tutorials, and some of them are longer. So the ones that we have time for today, you can choose the one that's called Name Tag or Rock, Paper, Scissors, and you can make your own rock, paper, scissors game. And this tutorial is going to walk you through how to program. Raise your hand if you are a computer scientist and you program computers. We got one or two in here, yeah? Oh, that's okay. You're probably going to be the worst at this. Because this is designed for young children to learn how to program, and even through high school age students. So this is designed for people who've never done any coding before. And it's block-based coding, so you can visually see how the code is going to work, okay? So when you click on one of these tutorials, either Name Tag or Rock, Paper, Scissors, it's going to give you the on-screen instructions for how to write the code for this. And for those of you that do have experience with code, maybe you can take a look at it and be helpful, all right? So go ahead and start the tutorial now. It should take maybe like 6 to 8 minutes to complete the tutorial, and then it will give you instructions on how to send this code to the circuit board because it's plugged in USB on your laptop. You have to write the program, then send the program to the circuit board, and then the circuit board will show whatever program that you wrote for it. Okay? So I'm going to just walk around and guide if you have any questions. If you can't see the laptop, please just gather around someone that does have the laptop. If anybody needs help, you could raise your hand and I could come around and take a look. But I see that everyone with a laptop has the tutorial going. Are you connected to the internet? Okay, here. So you need to visit the website, makecode.microbit.org. So now, let's scroll down. You guys work on there? Perfect. Good job. All right, so I've got one group that already finished the tutorial. Way to go. So who else is still working on the tutorial? This group right here. You can try another tutorial. The rock, paper, scissors is quite fun. Yes. So if you click, all of these are the menu and they open up and it's color coded. So the pink one, you need to open up the pink one and then it'll be in there. Yeah, you see? And then you just drag it over. Uh-huh.
In this space.
Yeah, anywhere in this space is the programming environment.
Okay.
Yeah, anywhere there. So those of you that are working on the rock, paper, scissors tutorial, one of the first blocks that you're going to try to open is called on shake. And so that means if you shake the circuit board. And so the circuit board can detect movement. So it has inside of the circuit board what we call an accelerometer. An accelerometer is a sensor that can measure movement. So it can measure movement on 3 planes. It can measure movement left and right, forwards and backwards, up and down movement. Same as your mobile phone. So then you can use the on shake program block. So when you shake the microbit, it can perform some function. I've brought with me one of another additional part to my microbit. On their LEDs and circuits, motors, and sensors. How are we doing on the tutorial? I've got a group that's done. Raise your hand if you also finished one part of the tutorial. Still working on it? You need some help? Do we have any rock, paper, scissors finished yet? I know some people were working on that one. So I think there's a lot of power in this programming environment. Like I said earlier, if you've never done any programming before, it's very simple for you to follow this tutorial and write a simple program. And the way that these program blocks are designed is that they're meant to be visual blocks that mean the same thing as JavaScript. Okay? So if you know how to program in JavaScript, these blocks are just a visualized way to program in JavaScript. And if you know how to program in JavaScript, in Microbit, you can switch to JavaScript programming, and you can write code like you normally would for JavaScript, and that code will also work on the Microbit. And even you can use Python as well. So if you program in Python, this is especially interesting for high school students who are in a computer science field. They already know how to program, then they can use this same editor to write programs for the Microbit. How are we doing on the tutorial? I've only got a few minutes left in the session. Perhaps you can stick around behind and play with these some more. We can keep them out all day if you like. We're good on time? Oh, I can go now? Okay. Yeah. Doing okay? Yeah. What's that? Yeah. So the automatically saved to your downloads folder. So if you open up your file viewer, okay, unplug the Microbit and then plug it back in. Okay, does it show up here on the drive? Okay, so yeah. Right, that will happen each time. Yeah, yeah. So instead of being inside of this folder, so go to your downloads folder. Yeah, click on the downloads. Yeah, but the way that it works on a Windows computer is you need to drag it over to the drive. Yeah, so if you just take the hex file and drag it to the Microbit, it seems to have a problem on Windows computers when you try to access it from the root file. So yeah, so it should copy over there, and then you see how this one is blinking? It tells you that the data is being transferred. Yeah. So then whatever code you have on here will show up, but then it automatically ejects. Automatically ejects. Mm-hmm. Yeah. But you didn't write any code for it. Write some code. Yeah, follow the tutorial, and put like the LEDs to blink on there, and then do the same process. Okay. You want to borrow it? $100. I'm not selling these ones. These are the ones I have for the conference that I use all the time. You can order online. Yeah, it's 1,000 bucks. No. Just people like yeah, they don't sell it on the site. All right, so I can extend this session about 15 more minutes. And so what I'd like to do is I want to demo some lessons and some curriculum that I've written about the microbit that is for use in schools in the middle school age group, like grade 7, grade 8. And it's contextualized in the area of learning about space, okay? So the project is called Microbit in Space. And it's about using the circuit board, but with the idea and the theme of things that happen in space with astronauts and rockets and this kind of thing, okay? So the question that I ask my students is, how do astronauts tell time in space? How do they calculate time, okay? It may sound like a silly question, but do watches even work in space? Do we know? We're not sure. So I always like to start my lesson off with a question to my students that makes them think. And sometimes it's a silly question, or sometimes it's just something to stimulate their mind, to get them interested in the topic of the idea, okay? So yes, of course, you can calculate time in space. As a matter of fact, it's very important to astronauts that they can calculate time. Here's a photograph of astronaut John Glenn, American astronaut preparing for space in 1962, and you can see in the photograph on his wrist is a wristwatch to use to count time. And when they were taking off, they would use a stopwatch to count how long it would take for them to reach a certain altitude, because that would tell them how much oxygen they have left in the capsule, which is quite important, right? As an astronaut, you want to have plenty of oxygen, okay? So with these lessons, we try to bring in concepts that they are learning about in science. So for these students, they would be learning in their science classroom about space travel, about space flight, the history of space flight, rocketry, this kind of things for middle school science. So for the microbits, we're going to make a stopwatch, and the stopwatch is basically going to count down for a number of seconds. So the microbit will start maybe like at 3 seconds, and then if you press the A button, it will count down 3, 2, 1, 0, and so on. It'll stop. And then in the program, you can change the variable, which is the amount of time that it takes for the stopwatch to work. Okay? So I've got, this is the code that you need to write to make the stopwatch. If that might be difficult for you to see on the screen, so I have provided digital instructions for how to write this code with the link here at the bottom of the screen. So those of you that don't have a laptop and you have the mobile phone, maybe you could be helpful with your team and follow this link to the digital instructions for how to write this code for the stopwatch, okay? Now this lesson is meant for students who have already completed 1 or 2 other microbit lessons. They've already done a couple of tutorials. They understand the basic mechanics of how to write the programs using this block-based programming language. And it is at this time where I start to teach more interesting topics in computer science, and we talk about logic So computers understand logic. They can understand do this thing or this thing. They can understand if this happens, then do this next thing. So we're using a logic block called an if-then statement. And so it's also using true and false statements. So along with this project, we're teaching them a little bit about computer science in the context of building something that they're learning about in the science classroom about space travel, okay? So I've got 10 minutes left. I'd like to see if possibly you can get through this countdown project. So whoever is your best coder in your group, take command of the laptop, and everyone else help by following along with the digital instructions on the link I provided at the bottom of the screen. Because if we get it done in time, I'm going to have you do some astronaut exercises using the countdown timer for the microbits. So it's incorporating the idea of play, right? So we're going to get up and do some things with it, okay? So if you could finish this code in like 6 to 8 minutes, that way we have time for the physical activity. And once again, I'm going to walk around and see if anyone needs help. That link's not working? Is anyone else having problems with that link? No. Can you see the screen? Can you see the code on the screen? Okay. So if the link is not working, I don't know why it's not working, but if it's not, you just look at the screen, and there is a on start loop, forever loop, and then on button A pressed, on button B pressed. If you were inside the tutorial on the microbit, you need to exit the tutorial by clicking on the home button, and then click on new project. So back to the home screen on microbit on the MakeCode website, then click on new project so you have access to all of the code blocks, okay? So if you're looking at my code on the screen, the red blocks, they're ones at the very top where it says set counter to 3, set counting down to false. The word counter and the word counting down are variables. And in computer science, we learn about variables. And a variable is just a way for you to store information so that you can use that information later in the code. So on the MakeCode website, in the middle column, you need to click on the variables, and then you need to make a new variable, and you're going to type in the word on the first variable, counter, and then you're going to make another variable and call that one counting down. If you need help with that, please let me know. What's that? So I've got about 2 minutes left. So if you could try your best to complete that code. I think this group over here maybe is going to get it first again. It's a little bit more challenging than the tutorial, because if you've never used this website before, you don't know where all of the code blocks are at. But I think one thing that is helpful is that they are color-coded. So you see there are dark blue ones. Those are basic. Then there are the green ones. Those are called logic blocks. The red blocks, those are called variables. And then we have a pause and a pink button for on button press, on A button press. And so on the code here where it says on button A press, that means the A button on the front of the microbit circuit board. So we're going to use those buttons to activate the program. How are we doing out there with the writing of the program? Almost there? So I think that even if you have never done computer science before and you don't know much about coding, the way that the logic works on this program is that it makes sense if you just read it in English, okay? So like in the forever loop, in computer science, the forever loop just means that it's going to continue over and over again. It's going to iterate every single time. When it finishes, start over again, okay? It says show the number counter, and the counter on the very top, it's set to 3. So when you turn on the microbit, the first thing you're going to see is the number 3, because that's the number of seconds. Then there's a logic loop that says if counting down is equal to true, then it's going to pause for 1,000 milliseconds, which is 1 second. And then it's going to change the counter variable by -1. So that's counting down by 1 every 1 second. So it'll go 3, 2, 1. Then if the counter gets to 0, then it changes the program to a false state, and then the program stops, and it shows only the 0. Now, on the right-hand side, I have on button A press, you can change the counter by 1. So automatically, the program is set to a 3-second countdown. But let's say you want to have a 10-second countdown. Well, then you just press the A button on the microbit. Each time you press, it's going to change the number of the variable from 3, 4, 5, 6, and so on. And then once you press the B button, you set the logic statement to true, which then makes the countdown start. So if you increase the value to 10 seconds, when you press B, it'll count down from 10 seconds all the way to 0. When it gets to 0, the program will be in a false state again, and it'll return back to its original state, okay? So even if you've never programmed before, this kind of programming, the block-based programming, I think it makes sense to students who've never done this before because it reads like English, and it makes sense when you follow the logic step by step. And so it's easy to introduce this to students, and they can learn a lot by this. And this is just a very simple project. As you can imagine, it can get much more complex than this. So how are we doing on the code, okay? Almost there? Well, I'm just about out of time. So if you want to keep playing with this microbit, I will put them out to the next room or something. But I just want to show you really quickly what we would do with this code. So after my students make the project, then I would have them work together in groups, and they would have to make a 10-second countdown timer, and then they have to see how many times they can jump in 10 seconds. And then set a 10-second timer, see if they can hold their breath for 10 seconds, and then sit-ups. And so this way we would start to become active with the microbit, and it's something that they can do, and they can get off their feet instead of just sitting on their desk with the computer. So this is where the play comes into it, right? Well, I think writing the code is playful as well, because you're working with another student and you're doing some new activity they think is quite fun. But then this really gets the body involved, and you get moving and involved with it. So then I relate it back to what the students are doing and learning about in the science class. Well, astronauts have to do exercise when they're in space. So this is how it relates back to what they're learning about in the curriculum. And I show a video of astronauts doing some exercises in space, and then they talk about how difficult it is and the timing that they have to do for that. So this is just an example of the curriculum that I write for schools, that it's based on this idea of constructionist pedagogy. Here's two final quotes that I want to leave you with about play from Albert Einstein and George Bernard Shaw. Play is the highest form of research, is what Albert Einstein says. And George Bernard Shaw says, we don't stop playing because we get old. We get old because we stop playing. So please be playful. It's good for your youth and vitality. And I'm going to end now, and this is my contact information, my email address, and if you follow on Twitter, is my information for Twitter. Also, here at the front, I have some brochure information if you're interested more about the curriculum and the resources that we design at BSD Education that involves these kind of ideas, computer science and the microbit, constructionist learning with website building and hardware. So thank you all for joining and attending this morning, but the session has now come to an end. Thank you.
Hi, thank you all for participating so actively. It was a very successful workshop. There's tea and coffee outside if you would like until 11 a.m. And then we're going to continue with a panel titled Humanity-Centered Education as Pedagogy for a Sustainable Society. If you would like to stay in here until 11 and keep playing, you can as well, and Mark will be here for any questions. There's also AMAs at the end of the day if you have any other questions. Thank you. See you later.